Okay, so back to this problem. We already understand that they're asking us to find the mean and the standard deviation of this sample. So the first thing that you'll want to do is you'll want to make a list of the information. And if you are diligent about this, you'll always make two lists, one about the population, and then the other one you'll make information about the sample. And the first thing we know that the sample is equal to 100. And we also know that the population is not normal. And the reason we can tell that it's not normal is because we look at it right here. Um, so we're looking at it. We see it's not normal because it's really shifted. What is that? It's right. It's skewed right. Um, and you've got all this other stuff. So it's not a normal distribution, but my sample size is greater than 30. So we're good to go. What that means is that we are going to have a normal distribution for our sample. This is going to be our sample of 100. And um, this is going to be the distribution for it. And it's going to be normal because it's the number that's bigger than 30. Now, this one says for the population, it says it has a mean. Now, notice I'm writing down the mean for the population is 6.8, and the standard deviation is 1.4. So 6.8, right about here, there's the mean. Okay. And then the standard deviation is 1.4 away. So we could, add the 1.4, add it again, add it again, add it again to find out where the standard deviations are. Not necessary though. Remember though, what I did tell you is that because the central limit theorem, we know this one's going to be considered normal because the sample size was big enough. We remember we wrote down in this thing up here that the means were always equal. So the mean of the sample will equal the mean of the population. So that means that if the population has a mean of 6.8, then the sample mean will also be 6.8. Okay. So when we're doing this over here, we'll get a sample mean of 6.8. Now remember, the standard deviation for the sample will always be smaller than this. We have to calculate the standard deviation for the sample. The standard deviation for the sample is calculated by taking this 1.4 and dividing it by 1.4 and dividing it by the square root of our sample size. Okay, so 1.4 divided by the square root of 100. I believe that's going to come out to be 0.14. So our standard deviation is 0.14. So you guys know how it works. One standard deviation away here, one standard deviation away here, one standard deviation away here, and I made mine really long. 1, 2, 3. You can calculate those numbers. I think that's 6.94. Actually, we're going to go over here and do it. So let's go to StatCrunch and go to calculators and go to normal distribution. And that gives us, now this is where everyone messes up. Because it asks for the standard deviation. You have to understand that we're doing this, remember, for our sample. This is for our sample. Okay, so that means that the standard deviation that we have to put in right here has to be the one that we calculated. So the numbers that we calculated was the mean is 6.8 and the S is 0.14. Okay, so 6.8 and Let me get this. So the mean is 6.8, and then the standard deviation is 0.14. Okay, and we're going to compute that. Remember to put our tick marks at the okay, we'll just put one. Oh. I don't know what's happening here. We'll put in 6.8. Okay. I don't know why I wanted a value, but anyway, I got those tick marks right there. So remember what I was trying to write, 6.94? I believe that's what I was writing. 6.94 was coming out. See how much prettier it was coming out over here? So here is the standard. Here is the what it looks like with the new standard deviation. A lot different than this one here, because see, they go all the way out to 11. Ours only goes out to 7.22. A smaller sample size is going to always make your standard deviation a lot smaller. Okay, so I wasn't trying to find a probability of anything today. I just wanted you to see how it, and that this building this right here is exactly what we were trying to do over here. We were just going to build that, and I was just going to put this would be 7.08. And then this is going to be 7.22. And these are going to be the numbers that were on it. And all I wanted to do is just draw this to show you the two. I'm practicing doing this new sample, this new standard deviation, calculating it and being sure that that is the number that you put in when you do it over here. What happens is everybody uses the 6.8 from the population, and then they put in the standard deviation from the population, and you get answers and they all look pretty and seem right. But that's because you're answering questions about the entire population, and you should be answering questions about the sample. Okay, so you do this next one. Remember, you can go back and look online. I have this next one, I believe, worked out on the teacher notes page as well. So just remember that you need to do the same thing that we just did right here. I will talk to you for just a second and show you that this one is for the population. It has a normal population. It only has a sample size of 4. Is that okay? Yes, that's okay. Why is that okay? Because the population is normal. The population is normal. The sample size can be smaller than 30. It's fine. Population is normal. The sample will be normal. The standard deviation is going to be a little bit different. So be sure you can show me what the drawing for the sample distribution would be. Okay. All right. I'm going to stop this video before I move on to the actually working a problem.